All right. So if I did all of the hypothesis tests for all the differences in means here, so all the pairwise comparisons, if I compared, the mu of the audiobook and the mu of the music, it was not significant. But if I compared audiobook and control, those are significantly different, and the music and control, those are significantly different. So I could kind of run through all of those. And then there's this problem that comes up that's called the problem of multiple comparisons, which is where if you do a lot of tests, you have a larger, it's called like family-wise rate. So if every test has an alpha chance of making a type 1 error, which is where you reject the null even though there's sort of nothing going on, then you have your overall type 1 error rate to be much higher. So if we had set alpha equal to 0.1 and we did 3 tests, then the family-wise error rate is 3 times 0.1, 0.3. So that's a much higher error rate. So we don't want that happening. We don't want to go kind of like doing bad statistics. I don't know if I have shown, I sort of feel like I have shown this XKCD comic in class before, but I'll just show it to you again. So this is about like significant relationships. So the comic says jelly beans cause acne, scientists investigate, but we're playing Minecraft. Fine. So they find no link between jelly beans and acne. And then someone says, I hear it's only a certain color that causes it. And then they go through and they look for a link between purple jelly beans and acne. No link. Brown, none. Pink, no. Blue, no, etc. They do this many, many times. They do find a link between green jelly beans and acne. And then, of course, the paper is just reporting, green jelly beans linked to acne. So the thing that's going on here, what makes this comic funny, is that you shouldn't be doing that many tests. They did 20 tests, so they would expect to find 1 out of 20 or 0.05 of them to be significant just by chance. So that's bad statistics. And so there's a few solutions to this problem of multiple comparisons. One is you should only do pairwise tests if the ANOVA shows significance. So this is another problem with that XKCD. They had initially said, we found no link between jelly beans and acne. Basically, they did the ANOVA and it was not significant. So they should not have gone on to do pairwise tests. You should only do the pairwise tests if the ANOVA shows significance. And then maybe you should only do a couple important comparisons, like don't do all of them. Or if you're going to do a bunch of them, use a smaller alpha level. So you could use the Bonferroni correction, which is alpha, whatever you want it to be, 0.05 divided by the number of tests. So in the case of doing 3 tests, 0.05 divided by 3, 0.016. So you could set your alpha level cutoff, make alpha cutoff smaller. And then you wouldn't be making a larger family-wise error rate. You would still be making a small number of mistakes.